Let's go ahead and take a look at number 1 here. So we're just solving systems using whatever method you want, and it looks like on this one that since it's in both of these equations are in standard form, it's going to be good to use elimination anyways, because if we add one to the other, we're going to eliminate these x's, okay? So since they're gone and we're adding, we'll still add the 5y and the 3y. We'll get 8y. This equals 23 plus the 1, which is 24. And we find, after dividing both sides by 8, that y is 3. Now this is only half of the problem. Y is 3. And that's because we have two variables. So in order to solve for x, all we've got to do is choose one of these two equations, and then we'll solve for the x value. Let's go and choose this top one, and it doesn't matter which one you choose. Let's go ahead and replace the y with a 3. Alright, now that we've got that, let's go ahead and multiply. So we're just doing any method we want to solve for x. Some of you may choose a switch and stay game. You'll have to multiply this first anyways, and that'll give you 15. The rest of this is still good. And from here we'll go ahead and subtract 15 from both sides. And it looks like we have a 2x equals 8. To finish this thing off, we'll just divide both sides by 2 and get x equals 4. Alright, so don't forget to write your answers as an ordered pair, and that's because it's a point on the graph. And the final thing also is that we should check our answer. So we use that top equation to solve for x. Let's go ahead and use the bottom one just to check our answer, okay? So in other words, we're going to write the equation, but we're going to replace x with 4 and y with 3. And whatever comes out, this just should make a true statement. Alright? So negative 2 times 4 is negative 8. 3 times 3 is 9. This is just order of operations stuff. Negative 8 plus 9 would give us a positive 1, which equals 1. And we've checked this off. So this is a good way on a test to know for sure that your answer is correct. It's almost like a legitimate form of cheating. I find it strange because even though we show you guys how to do this to check your answer, very few people actually end up using it because it's considered time consuming, okay? Well, that little bit of extra work just helped me to make sure that my answer is correct. So I highly suggest that you check your answers that way. Alright, so once again, these two equations are in standard form, so it's going to be better to use elimination in this. And we can look at these. There's not really a convenient variable to eliminate first. I suppose in the previous problem we got rid of x first, so let's go ahead and get rid of y first. We're going to choose to eliminate y. So in order to eliminate y, what we need to do first is look at the coefficients of y. And in this top equation we see that the coefficient is a 3. So what I'm going to do is I'm going to multiply 3 throughout this bottom equation. That'll give me a new equation. And it's just like distribution. So 3 times 3x gives us 9x. 3 times 2y gives us 6y. And 3 times 12 is 36. Now, we've got to multiply the top equation by the opposite coefficient of y. In this case is 2. So I'm going to take a 2 and multiply it into this parentheses. And that will give me an equivalent equation but it will give me at least the same coefficient of y, because that's the what I have chosen to eliminate. So I have 2 times negative 2x, that's negative 4x, plus 2 times 3y is 6y. This equals 2 times 5 is 10. So this is what we have now compared to what we used to have right here. The last thing we need to do is take a look, and we get to choose, because we need those signs of the coefficient of y, which is 6 here. We need those signs to be opposites. So let's go ahead and change the signs, but we have to do it to an entire equation. So let's go ahead and do it to the top equation. It doesn't matter, you get to choose. And it's just like multiplying everything by -1, where you're going to distribute that -1 into that equation. So that gives us 4x minus 6y equals -10. And the bottom equation is going to stay the same. We got 9x plus 6y equals 36. Now what I can do is just add these together. So 4x plus 9x is 13x. And what you'll notice here is that negative 6y plus 6y is 0. So these eliminate. And that's what we wanted to happen in the first place. We chose to eliminate the y's first. Negative 10 plus 36, because that's positive 36, it's going to give us 26. That's a nice convenient value, which now we can divide both sides by 13. And we find that x is 2. So don't forget that x being 2, that's just half of the problem. Our final answer is going to be a coordinate pair. And the x value will be 2. We just need to solve for the y value. To solve for the y value, what we need to do is go back to the original equations. And I'm going to go ahead and rewrite one of them. Now you're going to choose which equation you want to start with. I usually choose the top one just because it's kind of convenient. You may choose the bottom one. So let's go ahead and say that we chose the bottom one just because it doesn't matter, all right? So we have this equation, 3x plus 2y equals 12. This is our original. That's the ones we need to work with. But we are saying that x here is 2, so we're going to replace x with 2. This will allow us to solve for y. So 3 times 2 is 6, plus 2y is 12. I'll subtract 6 from both sides. I get 2y equals 6, and dividing by 2, I get y is 3. So on my coordinate pair I have y is 3, but this isn't finished yet, alright? Don't forget that we still need to solve the final equation, and so this is the equation that we didn't use. And we're just going to plug in the x and y values that we have just to make sure that we've done this correctly, alright? So negative 2x plus 3y equals 5. Alright, so all I'm going to do here now is, again, I'm going to replace x and y with those values. We had a 2 and a 3, alright? So let's get rid of those. And we're going to replace x with 2 and y with a 3. Alright, we'll see if this is a true statement here, okay? So negative 2 times 2 is 4, plus 3 times 3 is 9. Sorry, that's negative 4. This needs to equal 5. Negative 4 plus 9 is 5. So this is a true statement, and we are good on this problem, okay? Now you should have a calculator that you should be able to check all this stuff with, so that you're not doing everything by hand like I am. And hopefully that helps you, alright? But ultimately, in the end, this is our actual answer, okay? It doesn't matter that we have y equals 3 and x is 2. The answer is a coordinate pair, or an ordered pair, because it's a point on the graph. Alright, on number 3, we could rearrange this, and that would give us standard form, but we can see that one of these is in slope-intercept form, and that's fine, because what we get to do with that is substitute the y value, alright? In other words, y actually is 2x plus 1. So if we wanted to replace this y with 2x plus 1, we can, and that's what we're going to end up doing using the substitution method. Alright, now yes, you could graph, you could eliminate, the choice is yours, but looking at this I can see very quickly that I can substitute the y value for 2x plus 1. So let's go ahead and rewrite that bottom equation. We've got a negative 4x plus 2y equals 2. Okay, but once again we're going to replace the y value with 2x plus 1. Because that's what we're saying, y is 2x plus 1. From here, so we still have negative 4x plus, but in this case we'll distribute the 2. That's a 4x plus 2 equals 2. Combining like terms, we see that we have a negative 4x plus 4x. That's 0x plus 2 equals 2. And if I want, I can make that a phantom 0x, and that just gives me 2 plus 2. 2 equals 2. This isn't a bad thing. That's okay. Just don't forget, all right, that 0x is not the same as x. X is 1x. So what does this mean? 2 equals 2. Well, 2 will always equal 2. And that's okay. But since 2 will always equal 2, what this means is that this doesn't have just one solution. It has infinite solutions, okay? And what does that mean? Well, it just means that these two lines intersect everywhere, which means they are the same line. And you could see that. If you wanted to change this top equation into slope-intercept form, you would find that it would just equal y equals 2x plus 1. Okay? And you'd see that these two equations are the same. So this one has infinite solutions. And that's it. That's nice too, because you pretty much only have to do half of the problem. Alright, number 4. I'm going to go ahead and use elimination on this. And if I choose to eliminate the x's, we can see that that's a negative 1x. That's a positive 1x. So if I add these together right away, those will eliminate. They're the same coefficient, just opposite of x. So these eliminate. That's great. And we have 1y plus 3y is 4y. And then we have negative 3 plus 6 is 3. This gives us a fraction. This is going to be a y equals a 3/4. And that gives us the y value. We just need to solve for the x value now. Alright, so I'm going to go ahead and use that top equation. It doesn't have any other coefficients other than the negative for x. So if I were to rewrite this equation, I'd have negative x plus now y is 3/4 equals negative 3. So to solve this, I'll subtract 3/4 from both sides. And I end up with negative x equals a negative, I'm going to make this an improper fraction, and it'd give us a negative 15/4. Well, to get rid of that negative, I just need to change both the signs, and we see that x is 15/4. So I use that top equation. That allows me to use the bottom equation just to check my answer. And then I'll write the answer as a ordered pair. So that's x plus 3y equals 6. X we're saying is 15/4 plus 3 times y, which is 3/4, should equal 6. And if this is a true statement, then we're good to go. So 15/4 plus 9/4, does this equal 6? Well, 15 plus 9 is 24/4, which does equal 6. So this whole process here has checked this off. We can write our final answer as an ordered pair. We got 15/4 and 3/4. Alright, be careful because on number 5, this looks a lot like standard form, but it is not. That's x equals y, 4y plus 1. That's the bottom equation here. But the top one is 2x minus 3y equals 12. So the equals are in different places, even though they're in columns like you see them there. So what this means is that we have just a variable, x equals something, which is great because then we can substitute x with 4y plus 1, which we're going to do. So that equation is 2x minus 3y equals 12, but I can go ahead and get rid of that x right there, and I will replace it with what I see that x is, which is 4y plus 1. So I'm going to go ahead and put that in there, 4y plus 1. Now to solve this, I need to distribute the 2. I got 8y plus 2 minus 3y equals 12. If I combine these two like terms, 8y minus 3y is 5y plus 2 equals 12. I'll subtract 2 from both sides, and I see that 5y equals 10, which gives me y equals 2. Alright, since I have the y, I can go ahead and look back at that second equation, x equals 4y plus 1, and replace y with 2. So we've got an x equals 4y, which is 2, plus 1. 4 times 2 is 8, plus 1. X is 9. So we've got the y and the x. Let's go ahead and check this using our top equation, since we solved with both x and y, this bottom one, okay? Alright, so we have that. Let's go and replace that x and y. So x here is 9, and y is 2. 2 times 9 is 18, minus 3 times 2 is 6. That should be 12. 8 minus 6 is 12. So this is a good solution, and we can write it as an ordered pair. 9, 2. Alright, number 6 is pretty much the same. We're going to use substitution to solve this. And we can see we're going to replace the y in that top equation. So it would have been 3y minus 9x equals 9. But again, we're replacing the y with 3x plus 1. Distributing the 3, we've got a 9x plus 3. That was a plus. Minus 9x equals 9. Combining like terms, 9x minus 9x is 0x plus 3 equals 9. And so we end up seeing that 3 equals 9. Well, this is not a true statement, nor is it ever true. So we would say that this one has no solution. And that's what you'll write in where you need to write the answer. Alright, well, since 2 will always equal 2, what we have is a problem where we have an infinite number of solutions. And we're going to go ahead and write that answer as though it has infinite solutions. So this is a set of solutions where we were using x and y, and then just write one of the two equations. It doesn't matter which one. I'm going to go and write the one that's in slope-intercept form, 2x plus 1, and we're done. This right here is our answer. Alright, so number 7 has 3 equations, and what we're going to have to do is, and this one will take a little bit of time. It's alright. So what we've got to do is choose any 2 of these equations to work with. Now I see that bottom one has a fraction. I don't really want to deal with those right now. But what I can do is just choose these other 2 equations. So I'm going to use the top 2. I've got a negative 6x plus 12y plus 3z equals negative 6. And then the second one is 2x minus 4y minus z equals 2. Alright, well, I've got to choose which variable I want to eliminate. That will give me a new equation that I can work with. And I'm going to go ahead and choose to eliminate the x's. So in order to do that, they're already opposites, and that's fine. But what I can see, and some of you may see this as well, you can multiply both of them by the other's coefficient of x here. But some of you may realize that you can just multiply this by 3, the bottom equation by 3. That's going to give you opposite and, well, just opposite coefficients there. So if I distribute the 3 into this, okay, I'd have 6x minus 12y minus 3z equals 6. And the top equation is the same, negative 6x plus 12y plus 3z equals a negative 6. Now some of you have already noticed that as soon as we try to add these, 6x minus 6x is 0. Negative 12y plus 12y is a 0. Negative 3z plus 3z is 0. And 6 minus 6 is 0. Alright, so what does this mean? As it turns out, all this is telling us is that 0 equals 0. And that's always true. So, in other words, these first 2 equations are the same. And you can see they're just multiples of each other. So in other words, we don't really need one of them. Alright, and we'll just check that last equation to make sure that it only has one intersection as well. Okay? So, let's go ahead and go back to that. And this means that what I can do with those equations is just limit it to 2. Alright. So now what I have is this 2x minus 4y minus z equals 2. And this next one is a negative x plus 2y plus, we'll say that's a 1/2 z equals negative 1. So if I take that bottom equation and multiply it by 2, then I would have that top equation, 2x minus 4y minus z equals 2. That bottom equation would be negative 2x plus 4y plus z equals a negative 2. And what we notice here is that all of these are going to cancel out as soon as we add these 2 together. So as it turns out, both of these lines are the same. And we'll write the equation is part of the solution set, because now that there's more than one solution, it's a set of solutions. So let's go ahead and write that in there. We'll need the fancy brackets. I'm going to find something smaller to write with here. Fancy brackets. And we're solving for x, y, and z. And then you just get to choose which equation you want to write in, because they are all the same. I like that second one the best, so that's the one I'm going to write in there. But again, you get to choose. And this would be the answer. Alright, with number 8, I'm going to go ahead and use the same technique. I'm going to choose those top two equations for no other reason than that those are the two that I want to choose. So you get to choose the two that you want to work with. So I'm going to write them up here. 3x minus 3y plus z equals -1. And the second equation, 3x minus y minus z equals 3. So I can see I can either choose to eliminate the z's or the x's very quickly. And since the z's are opposites, I can eliminate them very quickly. So I'm going to choose to eliminate the z's. I'm just going to add both of these, and these will eliminate, okay, the z's. So I end up with 6x minus 4y equals 2. Well, that's great. That's a pretty nice equation there. So now that I've used the top two, I've got to use one of those two, and I will choose the bottom one. So I got a 3x minus y minus z equals 3. And I've got that bottom equation, so I'm using these two, the middle equation and the bottom one. Got a negative 6x plus 4y plus 3z equals -8. Alright, with these two, it looks like I need to eliminate the z's. And since there are already opposite signs, I need to multiply this top equation by 3, okay? So that would give me a 9x minus 3y minus 3z equals 9. And the bottom equation stays the same. Negative 6x plus 4y plus 3z equals -8. Now when I combine these, those z's are going to cancel out. And I'll have 3x plus 1y, or just y, equals 1. Alright, let's look at these two together, because now we have to look at these two and solve for x and y. So if I stack them this way, actually I'll go ahead and rewrite those. Alright, so I have these two equations, and what I need to do is choose which variable I want to eliminate. I'm going to choose y's, since they're already opposites, and I can see I need to multiply this bottom equation by 4. So the top equation remains the same. And you could say it remains the same because I multiplied it all by 1, which is the coefficient of y in this bottom equation. Now when I distribute that 4 in there, 4 times 3x is 12x, plus 1 times 4, 1y times 4 is 4y, equals 1 times 4 is 4. And I can eliminate these right now. You can see the y's will eliminate, and I end up with an 18x equals 6. So dividing by 18 on both sides, we get x is 6/18, which is 1/3. Next thing we need to do is solve for y, and we only need to use one of these equations, which looks like I'm going to use that bottom one because it has a coefficient of 1 for the y. 3 times 1/3 plus y equals 1. Well, 3 times 1/3 is 1 plus y equals 1. It looks like y is 0. So going back to this, we have x is 1/3, y is 0. We just need to solve for the z value now. And you get to choose whichever equation you want. So just for the sake of randomness, I'm going to choose that bottom equation. We got a negative 6x plus 4y plus 3z equals negative 8. Negative 6 times 1/3 is a negative 2. 4 times 0 is 0. Plus 3z equals negative 8. And yes, we don't need that 0 there. So what we'll do is add 2 to both sides. That gives us 3z equals negative 6. Finally, z equals negative 2. Just divide 3 by both sides there. Alright, working with these equations, so we use the bottom equation, so we don't really need to use it again to check our answer, but we'll use those other two, okay? We got a 3x minus 3y plus z equals negative 1. Now, I've noticed on some of the problems you guys have been having trouble with this. Okay, you write it like that so you can see that it's plus that negative 2. Otherwise, you may get the signs mixed up. Alright? 3 times 1/3 is 1 minus 0 plus, well, that's a minus 2 and negative 2 equals negative 1. And that's true. And negative 1 does equal negative 1. That means we've checked using the top equation. So the last one we need to check is that middle one. We've got a 3x minus y minus z equals 3. And that's going to be a plus there. So we got 1 minus 0 plus 2 equals 3. And that's true. 1 minus 0 is 1 plus 2, 3. So this checks off. Final thing we need to do is write our answer as a ordered triple. And looking back at that answer, it looks like we get x is 1/3, y is 0, z is negative 2. Alright, let's go and look at number 9. And on this problem, we're just going to take the same approach as we did with those other ones, alright? So let's go and put it up here. And let's choose those first two, okay? So we're going to work with these top two equations right here, okay? So let's say that I'm going to eliminate the z's. So I'll rewrite those to the right. We've got x plus 2y minus z equals 5. And beneath we got 6x plus y plus z equals 7. Well, I can see very easily that I can eliminate the z's right here. So if I add these two equations, I would get 7x plus 3y, these eliminate, equals 12. That's our first equation. Now I'm going to choose that top equation, x plus 2y minus z equals 5. And since I haven't used that bottom equation yet, I'll have to combine it with this top equation. Alright, well I'm going to need to multiply this top equation by a negative 2. I can just multiply it by 2. I'm going to take a shortcut. That's going to give me an equation. I'm going to write it right here. I've got a negative 2x minus 4y plus 2z equals negative 10. Alright, so I'm just looking at these two right here, and I can immediately add everything together. Well, it looks like these cancel, the y's cancel, and the z's, so we get a 0 equals 5 minus 10 is negative 5. Well, this is not true. So as it turns out, these two equations will never meet. And how is that helpful? Well, as it turns out, it's very helpful because we don't have to do any more work on this. This just tells us that since two of these never touch, there's not a common solution for all of them. This one's a no solution. Alright, for number 10, we got tickets to go see a Christmas Carol. And they're going to cost 36 bucks. Student tickets are 26 bucks. So there's a couple things we're comparing here. A school group purchased 51 tickets at a cost of $1,548. How many of each ticket did they purchase? Well, let's go ahead and figure out. The first thing we need to do, again, is to compare. We can see that we're comparing costs to tickets. And also we're comparing adult tickets to student tickets. Alright? So this kind of creates a little matrix for us, or a table, where we can compare these. Alright? So in other words, right here, this is going to give us an equation for costs, or dollars. And the bottom one here is going to give us some type of equation for number of tickets. So if we look in costs, we're going to have adults are $36, and we'll say that X is the number of adult tickets. So it's $36 for every ticket, 36 times the X. We're going to add that to the student tickets, which we'll say is Y, number of student tickets. Well, how much was the cost of the student tickets? Well, it's $28 each. And in terms of cost, so the final thing we're going to compare here is the total. And how much total was spent? Well, we can see there it's $15.48. In terms of tickets, it doesn't say how many of each was sold. That's what we're searching for. Adult tickets plus student tickets. But it did tell us exactly how many of both together were sold. It's 51. And what we've done is we've created a system here. 36x plus 28y equals 1548. And x plus y equals 51 that we can use to solve this system. So I'm going to go ahead and rewrite those so that we can see them separately. 36x plus 28y equals 1548. And we also have x plus y equals 51. Alright? So looking at this, now we have this new system. We need the same coefficient, so I'm going to multiply this bottom equation. Let's choose to eliminate the x's first. So I need to multiply this bottom equation by 36. So with my top equation, which remains the same, we still have this 36x plus 28y equals 1548. But now my new bottom equation here is 36x plus 36y equals 51 times 36. $18.36. Now we do need to change the signs on these, so we can go in and We'll change the signs of the top one. Okay, so now these are all negatives. Now when we add these, the x's we see will eliminate. And we have 8y equals 1548. The difference between these two. $288. Finally solving for y. Looks like we'll get 36. So since y is 36, we could say right now that they sold 36 student tickets, but we still need to check for the x. I'm going to use the top equation to do that. I got 36x. I need to solve for x. I'll replace the y with 36 equals 1548. 28 times 36, 1008. Now I'll subtract 1008 from both sides. It's a net of 540, looks like. And dividing by 36 will give me the x value of 15. So we have an x and a y value. Let's go ahead and just check that. I'll use that bottom equation. X plus y equals 51. But of course I need to replace the x and the y with those values. I got a 15 plus 36 needs to equal 51. And as it turns out, it does. 51 equals 51. So now we define these as x and y, but since this is a word problem, we actually need to say what these are. Because the original question was, how many of each ticket did they purchase? Well, we know they purchased x, and before we had defined x as the number of adult tickets. So we would say they sold 15 adult tickets. And 36 student tickets. Alright, so on this one we're going to go and write the two equations, and again it may be helpful for us to define our two variables. We're going to use x and y, but you may use any other two letters you want. It's usually just not normal to use L and O. So you look like a 1 and a 0. Alright, so just be careful with that stuff. But again, it's not really going to matter here because we're going to write out our answer as a sentence. So on this one we see a mixture of M&Ms worth $2 per pound and trail mix worth $1.50 per pound. Find how many pounds of each you should use to get 50 pounds of party mix worth $1.80 per pound. Alright, so we need two things. How many pounds of each? So we talked about pounds of M&Ms. And we also talked about pounds, what we want to find is pounds of trail mix. Alright, so to write these two equations, now the first thing we're going to do is look at an equation that has to do with money. And the second we'll look at and we'll compare pounds. Alright. And in these equations we're going to compare M&Ms and trail mix. And that should give us some total amount. both in terms of dollars and pounds, okay, because it gave us that information down here. Well, for M&Ms, it's $2 per pound of M&Ms. We'll add that to $1.50 per pound of trail mix, which is our Y. Alright, so we need a total for the dollars, and we know the dollars per pound. We don't know the total amount it's going to be, so we have to multiply those two. So what we're going to have to do to figure out that total is we're going to take, I'll do this in a different color, we're going to take that 180 per pound and multiply it by the 50 pounds. Okay, and we'll see how much that is. Looks like it's $90. So the total was actually $90 there. Now if we look at M&Ms, we don't know how many pounds of M&Ms we're going to get, or trail mix yet. But we do know that we're going to purchase 50 pounds there, alright? So this is great because it allows us now to take these two equations, and I'm just going to write them separately so that we can do some work with them. You don't have to do that, but I'm just going to do it for the sake of space. Alright, so let's go ahead and take this. We got these two equations. What we need to do is figure out which one we want to eliminate. Since the Y has a decimal, I'm going to go ahead and choose to eliminate the X's, but you may choose to do what you want. So I need a common coefficient of X to be 2, and right now it's 1. So I'll just multiply everything in that equation by 2, and what I'll get is 2x plus 2y equals 100, and the top equation stays the same. Alright, well, we need those coefficients to be opposites, so what I'm going to do is go through these and change the signs of each one. And when I add these eliminate. I've got a negative 0.5y equals negative 10. Finally, just dividing by negative 0.5 on both sides. That's going to make y a positive 20 there. So if we go back to this, that we know that y is the pounds of trail mix, we would say 20 pounds of trail mix. Alright, so we have that part. Now what we need to do is solve for x, and we can see this bottom equation is going to be very easy to solve for x. So if we replace x now, actually I'll rewrite this, x plus y equals 50. Now, replacing the y with the 20 pounds that we found it to be, you'll find after solving that x is 30. So we need 30 pounds of M&Ms. So since we used that bottom equation to solve for x, we still need to use that top equation just to check our work. So we're going to go ahead and write that 2x plus 1.5y equals 90. But again, we'll replace the x with the 30 pounds and the y with 20 pounds there. So 2 times 30 is 60, plus 1.5 times 20 is 30. This should equal 90, and it does. 90 equals 90. So we checked our work, and we have our answer. We've written them both separately there. And there we go. 30 pounds of M&Ms, 20 pounds of trail mix. Alright, number 12, you can row 10.6 kilometers in 1 hour downstream and 6.8 kilometers upstream in 1 hour. Find how fast you can row in still water and find the speed of the current. Okay. Well, downstream means that the stream is going with you, if I understand that correctly, and upstream would be against the current. So, if we take, and we need two equations again, right? We need a downstream, that's a D, downstream and an upstream equation. And what we need to compare is your speed against the current. So we'll write those out. You have yours and the current. And then what would happen is that you'd have your final speed, okay? So when I say your speed, I'm really talking about your speed in still water there, all right? So if you're going downstream, you're going to take your speed, which we don't know, x, and we're going to add the current speed, which is going to help us to go faster, y, we'll say, and that'll tell us the final speed, which is 10.6 kilometers per hour. So your speed will be in kilometers per hour, and so will the currents. And from here, we need to write now against the stream, upstream, you have your speed against the current, which is y, gave us a 6.8 kilometers per hour. Now, yes, I should have defined these. Let's go and write those out now. X is your speed. Y is the current speed. And from here we can see we can actually work with these directly right now in order to eliminate y. So if I add these, I'll get a 2x equals, looks like it's 17.4. And we find that xr speed is going to be, looks like it's 8.7. And that's in kilometers per hour. Alright, so this is your speed is 8.7 kilometers per hour. Now what we need to do is figure out the current speed. Now, some of you may know this as well. And I'm just throwing this in there, so if it's not going to make sense to you, just don't worry about it, okay? Just skip this part. But 8.7 is the average between these two. So if you added those two together and then divided that by 2, you'd find your speed there, okay? Now to find the current speed, let's go ahead and do that. Alright, so we have that x. Let's go ahead and use the downstream current. So x, which is 8.7, plus y equals 10.6. So to find the speed of the current, let's subtract this 8.7. And we'll find that we have this is a negative 1.9 is what it looks like. I'm sorry, not negative. It's a positive 1.9. I apologize. So y equals 1.9, and that's in kilometers per hour. So that's the speed of the current. We're just going to check this real quick using the bottom equation here. And we'll use that bottom equation because we use the top one to solve for y. So this will help us to check. So x is 8.7 minus the y, which is 1.9. This should give us 6.8. Let's find out if it does. Go ahead and put that in a calculator or just do it by hand. You'll find that it's 6.8. And we've checked this thing. We have our two answers. speed of the current, and R speed in still water. Alright. This one, it looks like we just need to figure out the break-even point for this company, which purchased $3,000 worth of new equipment. And that's a cost right there, so purchased. So we have the costs. Then you also have revenue. Alright, and in comparison to these, revenue is positive and cost is negative. So when we find a cost, we're going to have to subtract it. And we can see that $3,000 is a subtraction from revenue. The cost of producing a package of stationery is $3. So in other words, we're going to subtract that $3 for stationery times the number of products that we need to sell. The revenue looks like they're going to get $5.50. And again, this is positive for every package of stationery sold. Alright, what we want to know is when this will be 0. Well, we just need to solve this as though we would any other equation. You'd combine 5.5x and negative 3x. So you'd have 2.5x, and then you'd add 3,000 to both sides. That way the x's are on their own side of the equal sign. You've got 2.5x equals 3,000. And you'd find that x equals 1,200. So you'd have 1,200 packages. And that right there is our answer. Alright, so number 14, this is just another one like, I think it was number 11 above, where we're going to look at, we have one solution that contains 99% acid and another with 0% acid. And what we want is 1 liter of 5% acid solution. Alright. So, the solution, we can look in terms of percentage, and then we can also compare liters. Alright, then we're also comparing the 99% to the 0%. And also the 5%, okay? So if we look at percentages, we have 99%, and we don't know how much of that solution we are, so that we're going to need. So we're going to say X is the 99% acid solution, which means Y is the 0% acid solution. So we'll add this to 0y equals 1 liter of 5%. So 1 times the 5 is still going to be 5% here, okay? Alright, and then on the other hand, we're looking at liters. We have X liters of 99% acid solution plus Y liters of 0% acid solution, and that would give us 1 liter. Alright, well, looking at these, as it turns out, looks like we're not even going to have to solve it like we would a regular system, and that's okay. Because if we look at this, we have an equation where there's no y. You just have 99x equals 5. So all I did was eliminate the 0y. If I figure this out, I have x equals 5/99 So that's 5/99 liters of 99% acid solution. So this is my first answer right here. Next, what I've got is I'm going to use that second equation with liters to solve for the y. So we have x, but we know now x is 5/99 plus y equals 1. So to figure out y, we just take 1 minus 5/99 and we'd get 94/99. And I'll have to write my answer up here. So we have 94/99 liters of 0% acid solution. Alright, that's my second answer there. Next thing I could do is just check to make sure that this works in the original equation that we haven't used, which is 99x plus 0y equals 5. And you'll see 99 times 5/99 is 5, plus 0 times that 94/99. That's going to give us this 1 liter of 5% solution there. Alright, and that's perfect. Alright, in 15 I'm going to graph the Y-intercepts first. And I'm going to go ahead and do this top equation in red. So I'm going to start at -5, and my slope is 1, so I just go up 1 to the right 1, up 1 to the right 1, and I continue this pattern. But I can also go to the left down 1 and to the left 1, so that gives me my full line. And yes, I apologize, my points are a little off there, but that'll work. Now, this is a solid line because the inequality is also equal to. Next, I'll go ahead and graph this next line in purple. You can see here. I'll start at my Y-intercept at 0,3, and I'll use the slope to figure out these other points. Alright, and this is also a solid line, so we'll go ahead and put that in. Alright, so the next thing we need to do is just test some points, and we know 0, 0 is not on either of these lines, so if I look at the red line first, I'd have 0 is greater than or equal to 0 minus 5, which means 0 is greater than or equal to -5, which is true statement. So I know I'm going to have to shade above that red line, and you may want to indicate that using some method. I don't know what you're going to want to do. Right here, I'm just going to kind of shade it a little bit there. The next line we can see we're going to use 0, 0 as well. So 0 is greater than or equal to what would be 0 plus 3. Well, this is false, so I'd have to shade in the opposite direction from where 0, 0 is on that purple line, which is here. So we can see that they're intersecting in this area. So I'm going to go ahead and get rid of those and just shade that area. And I'll go ahead and use a different color just to make sure that we know that this is the shaded area. And yeah, it looks pretty good, alright. Alright, number 16 is the same thing, and 15 was the same as well. As in the previous chapter we had unions and intersections, and it's the intersection of these that we're looking for amongst these three equations, or inequalities rather. So some of you may choose to write these in slope-intercept form, whatever is convenient for you. I'm going to go ahead and do that just because it's usually the easiest way for students. So go ahead and try that actually, and then check your work. You may want to pause the video. Alright, so there we go. That bottom equation is not going to change. Inequality, rather. So we can see in that second equation, we're going to have a problem there with y-intercept being a -2/3. That's not a big deal. because from standard form we can find the y-intercept. Let's go ahead and take a look at that. Alright, but I'm going to keep that slope-intercept form just because it gives us a slope. All we need to do is find a point that gives us two integer values for both y and x. And it looks like the y-intercept here is 0, negative 2/3. So that's not going to help us out. But also the x-intercept looks like that's going to be a negative 2/5. So that's not going to help us either. So we just need to plan some points and see if we can figure out one that's going to work for us. Now, it may take a while to do this. It's really up to you, but you just need to figure out some points to work with on this graph. So I'm going to go ahead and choose y is 6. And the reason I know that is because what I need here is pretty much just this to give us some multiple of 5. And if I use y is 6, I'll get 18. So when I bring it over, it'll give me a multiple of 5, okay? So if I have the rest of that equation, 5x plus 3, y is 6, you'll see this work itself out. So from here, we got 3 times 6 is 18. Still have the 5x. And again, I'm not too worried about this inequality because I just want to know where it's equal to so I can find a point on the line. So when I subtract 18 from both sides, that'll give me a multiple of 5. So I still have that 5x, and this is going to be negative 20. Dividing by 5 gives me my x value. X is negative 4. So it gave me these, what I have here. So I have these coordinate pair, and we said that y was 6. And we found that x is negative 4. So I can plot this point. Negative 4, 6 would be right about here, okay? So that's, again, this middle equation. And we see that the slope is negative 5/3, so I'll go down 5. And to the right 3, which puts me right about here. I'll repeat that process on the graph. And I can't go to the left anymore from where I started. But looks like we have all these points. Now this is going to be a solid line because it's also equal to, so let's go and graph that. Alright, that looks pretty good. And I can't really tell where that goes through 0, 0 or not. But what I'll go ahead and do is just check with the point 1, 1 in that original equation. So let's go give ourselves some space. And 1, 1 is not going to work for this. We can see you'd have 5 plus, oh, I'm sorry, it is going to work. Negative 2, so 8 is greater than or equal to negative 2. So I'm going to shade above this line. And again, I just have that there just so I can remember where I need to shade once the drawing is done, okay? So that top equation, we'll go and do that in red. So we're going to have a point at the origin. And we'll just use this slope to figure out these other points. Now it looks like this line is the same one as the first one that we plotted, but as you'll see, they're starting to drift away there. Alright. So it's going to be a very thin margin for these two because 1, 1 is not going to work for this equation. So far, and let's go ahead and look at that. So far, I just have this little tiny area that should be shaded in. Now, that may change a little bit once we graph this next one. let's go ahead and try that out. So I'm going to put this one in green. Y is 4 right here, and it's just that line Y is 4. So let's go and put that in. So it's a little bit longer than I needed. That's all right. And so if we zoom into this, we can see the only place we're going to shade in is this area right here. Okay. Just a very small sliver. The rest of that is not going to matter. Alright, so the solution to this one is actually just the green shaded area there. Alright, that first equation, I'm going to go ahead and put that into slope-intercept form for you. You can try it, pause the video if you want, give it a shot. This is what you should come out with. Y is greater than or equal to 2/3 x minus 2. Now notice that the inequality flipped there because we divided by this -3. That's not a big deal. So let's go ahead and graph that equation. I'm going to graph it in red. And I just draw that line there just so we can know that that is the line, the red line. So at -2 I have this point. I'll go up 2 to the right 3, up 2 to the right 3, and I'll continue this, but I'll also do it in the other direction, down 2 and to the left 3. Alright, so there we go. This is going to be a solid line because those points on the line are also equal to it. Then we also have that, if we test the point 0, 0 on this, it's going to give us a true statement, so we know we'll shade above that, okay? Next, we'll go and graph Y is less than or equal to 4. So that'll give us this line, about like this. And again, that's a solid line as well. And we'll have to shade below, so it should be at least in this area. But then in addition to that, we also have that x is equal to 0. That's the y-axis. And again, this will be a solid line. And x is greater than that, so it'll be this shaded area. Now notice I'm not putting shading where I know it's not going to be. I just need the intersection of this. And finally, we'll do y equals 0, which is the x-axis. So about like this. And we can see now the green is the true answer for this. Yeah, you'd want to figure out a way to get rid of that other stuff. Okay, something like this, just to indicate that we know that that green shaded area is the actual answer. So it looks like it's some type of trapezoid, and that's okay. So there we go. All right, number 18. Robin can run twice as fast as she walks. If she runs for 12 miles and walks for 8 miles, the total time to complete the trip is 5 hours. Find her average speed walking and her average speed running. Alright, so let's go ahead and let x equal walking speed. And we know that running is 2 times that, so this is running speed. So if we go running for 12 miles, so 12 times the running speed is 2x, plus 8 miles while she's walking, which is just x, should give us, well, that's 20 miles in 5 hours. That's 4 miles per hour, okay? So working this out, we'd get 24x plus 8x equals 4. And that'd give us 32x equals 4. So walking speed looks like it's going to be 4 over 32 is 1/8 miles per hour. And running is just 2 times that, so this is walking. Running would be 2 times that, so 1/4 of a mile per hour running.